Hi guys, I was making a video on one of the problem from section 6.5, number 35, that we are asked to find the inverse of this 2x2 matrix A. A student had a question about how to find the inverses of a 2x2 and a 3x3. Now 3x3 is going to be a little bit longer, so I want to see if I can, because I have only a limited amount of board here, so I want to see if I can find a good video on YouTube for you for a 3x3. If I do, I'll upload it for you. If not, I'll try to make one myself. But I'm going to start with a 2x2 because it's a similar idea. So I was actually in the middle of making the video and then I got it cut off. So I'm going to go ahead and just explain what I have so far. This is problem number 35. The matrix, we're given matrix, I'm going to call it matrix A. So we're going to find its inverse, okay? So this is how we write the inverse A with a -1. So that's the question. What is going to be the inverse of this 2x2 matrix? So what we need to do, we need to go ahead and, let me just take this off. We're going to form this augmented matrix. So this is called the augmented matrix, and the way we do that, we put our original matrix on the left-hand side, and then we put the dotted line, and then we form this is called the identity matrix, a 2x2 identity matrix, which has ones around the diagonal, and then also zeros everywhere else. Okay, so our task is to be able to take this augmented matrix and change it so that now the identity goes on the left, and then of course whatever four numbers we get on the right hand side, so I'm just going to put them as a question mark right now, those four numbers will form your inverse, right? So once you get this augmented matrix to become in this form, then those four numbers will give you the inverse of your matrix. Okay, now to be able to do this, to go from here to here, there are certain things called elementary row operations. So you can take any row, multiply by any number, and that's equivalent to the original augmented matrix. You can take any row, multiply by a number, and add it to another row, and then replace that with that row, okay? So these are all allowed to be done. So all we gotta do is do them to see if we can go from here to here. For example, right now you have -1 in the very first position, but you want that to become 1. So obviously, we're gonna multiply the top top row by -1, okay? So that's going to give us, now don't forget, we're not changing the second row, we just changing the top row right now. So -1 times -1 becomes 1, -1 times 2 becomes -2, and then also -1 times 1 becomes -1, -1 times 0 will remain as 0, okay? Now the second row doesn't change, because we just changed the first row right now. So we still have that. So now we want to make, the next thing is to make the number 1 0, because remember you want to go from here to here. So right now we already got our 1. Now we want to make that 0. So we're going to multiply top row by -1 and then add it. We're going to add that to the second row and then replace that by second row. So top row is going to stay the same, which is going to be 1, -2, and then -1 0. Now the bottom row we're going to replace by multiplying top row by -1, add it to the second row. So -1 times 1 becomes -1 plus 1, which becomes 0. There's your 0. And then -1 times -2 become +2 plus -1, which will add up to 1. -1 times -1 is 1. 1 plus 0 becomes 1. And -1 times 0 remain as 0 plus 1, which remain as 1. So actually, one more step we should be done. So the last step is to make the -2 0. And then you have your 1, 0, and then of course, this is already 1. So we just make that 0, and then we should have our inverse. So to make the -2 0, you're going to multiply the second row, I should say, by 2. And then you're going to add it to the first row and then replace that by first row, okay? So let me just go ahead and take this off on the top. That way we can write it up there. Okay, so from here, don't forget what we're doing here. We're multiplying the second row by 2, add it to the top row, replace that by top row, and that's going to make our -2 0. So 2 times 0 is 0, 0 plus 1, of course, remain as 1. 2 times 1 is 2 plus -2, and there it is. There is your 0. 2 times 1 is 2 plus -1, which becomes 1. Let me do that one more time. 2 times 1 is 2. 2 plus -1 becomes 1. 2 times 1 is 2 plus 0, which becomes 2. And then, of course, the second row stays exactly the same, which is 0, 1, 1, 1. So as you can see, we are done because we just changed our original matrix to this form. Remember, we had to get 1, 0, 0, 1, which we have. Now, whatever 4 numbers show up there, that's your inverse. So in this case, the inverse of this matrix is the matrix with 1, 2. Remember those 4 question marks, which we just found? And that is the inverse of your 2 by 2 matrix. I hope this helps, but I'm sure the book has more examples. I'll try to see if I can find you a YouTube video on a 3 by 3 matrix. It's almost the same exact ideas. So if I can't find any good one, I'll try to make one myself. It's just that my board is so small, it's going to be a lot of erasing involved. But let me see what I can find for you on the 3 by 3. Thank you.